A new era of cosmic discovery featuring Bill Nye and the James Webb Telescope, opening music and visuals. For decades, Bill Nye, the science guy, has inspired generations with his passion for science and exploration. From chemical reactions in the classroom to the far reaches of space, Bill has always made complex ideas fun, accessible, and thrilling. Today, he's turning his attention to one of the most groundbreaking achievements in modern astronomy, the James Webb Space Telescope. After years of anticipation, the Webb Telescope, often called Hubble's more powerful successor, is now operational and it's delivering astonishing results. Launched on Christmas Day 2021 by NASA in collaboration with ESA and CSA, the telescope spent months unfolding and calibrating its highly sensitive instruments nearly 1 million miles from Earth. By June 2022, the telescope began sending back its first images, revealing the universe in unprecedented detail. Thousands of ancient galaxies, previously invisible, are now being seen, some of them older and more distant than any we've observed before. In fact, some galaxies might have formed 150 million years earlier than those seen by Hubble. This changes our cosmic timeline in ways that astronomers are still working to fully understand. Unlike previous telescopes, Webb uses infrared light to peer through dense clouds of dust and gas that obscure our view. This allows scientists to see the hidden processes behind star and planet formation. According to Bill Nye, this is like having a time machine that lets us observe the origins of the universe with unmatched clarity. One of the most iconic examples is the new view of the pillars of creation in the Eagle Nebula. Previously imaged by Hubble invisible light, this structure is now seen with incredible depth through Webb's infrared sensors. The pillars, massive clouds of gas and dust, appear more translucent, revealing protostars in their early stages of formation. These young stars appear as tiny red dots within the image, but in reality, they are enormous, many times larger than our entire solar system. Bill Nye explains that as more material gathers at the core of each protostar, gravitational pressure causes it to heat up. Once it reaches around 2 million degrees C, nuclear fusion begins and a new star is born. The Webb image of the pillars not only showcases the telescope's extraordinary resolution, but also demonstrates how stars like our sun are created. Different colors in the image represent various infrared wavelengths, invisible to the human eye but essential for detecting heat signatures in deep space. This kind of imaging is also unlocking mysteries around exoplanets, planets orbiting stars outside our solar system. Since the 1990s, scientists have discovered over 3,000 confirmed exoplanets. However, only a small number have ever been directly imaged until now. In September 2024, the Webb telescope captured a direct image of HIP 65, 426b, a massive gas giant nearly 12 times the size of Jupiter. This planet orbits at an extreme distance, 100 times farther from its star than Earth does from the Sun, making it easier to observe with Webb's infrared sensors. To isolate the planet's faint light from the bright glare of its host star, astronomers used advanced coronagraphs and multiple filters. Bill Nye emphasizes how this technological feat brings us closer to understanding not just distant worlds but potentially habitable environments beyond Earth. In addition to this, Webb has helped scientists study WASP-39b, an exoplanet located about 700 light-years away. This gas giant orbits very close to its star, only 1/8 the distance between Mercury and the Sun. Due to its proximity, the planet's atmosphere is extremely hot and dense, making it a perfect candidate for atmospheric study. Webb detected key chemicals in WASP-39b's atmosphere, including carbon dioxide, sulfur dioxide, and silicates. These findings mark the first time we've been able to detect sulfur-based molecules in an exoplanet's atmosphere, a major step forward in understanding alien chemistry. As Bill Nye puts it, this is the kind of data that makes the search for life beyond Earth more exciting. The edge of the universe, Webb's deepest discoveries yet. Opening music and visuals. Welcome back. We explored how the James Webb Space Telescope is revolutionizing our view of the cosmos, from imaging exoplanets and protostars to revealing hidden galactic structures. Now, let's push even deeper into space and time with insights that take us back to the very dawn of the universe. One of the most jaw-dropping accomplishments of the Webb telescope so far has been the discovery of 4 of the oldest galaxies ever observed. These galaxies existed just 350 million years after the Big Bang, when the universe was only about 2% of its current age. Scientists determined the galaxy's age using a phenomenon called redshift, which measures how much a galaxy's light has stretched due to the expanding universe. Using Webb's near-infrared spectrograph, astronomers confirmed a record-breaking redshift of 13.2, making this the farthest we've ever seen into cosmic history. According to Bill Nye, this isn't just about how far we can see, it's about what we're learning. These galaxies shouldn't even exist this early in the universe, according to our previous models. Yet there they are. But Webb's eye isn't just focused on the past. It's also helping us understand the present structure of nearby galaxies, including the hauntingly beautiful Ghost Galaxy, or M74. Though faint when viewed from Earth, Webb's infrared imaging has revealed glowing tendrils of gas and dust spiraling from the galaxy's core. These filaments appear like glowing threads, tracing regions where new stars are actively forming. Combined with Hubble's optical data, the image creates a stunning composite view, blending the seen and unseen parts of the galaxy. This is part of the PHGS project, an international collaboration aiming to map 19 nearby galaxies in incredible detail. Even more dramatic is Webb's image of Wolf-Rayet 140, a massive star nearing the end of its life. Surrounding the star are wavy concentric rings of gas shaped by intense stellar winds and interactions with a smaller companion star. These rings are not imaging artifacts. They are real physical structures that help astronomers understand how stars shed their outer layers before exploding into supernovae. The clarity of this image, right down to the slightly square shape of the outer rings, demonstrates Webb's sensitivity and precision like never before. Meanwhile, ongoing research using Webb is helping astronomers understand the life cycles of stars, the composition of interstellar dust, and the evolution of galactic structures across billions of years. Bill Nye sums it up perfectly. The James Webb Space Telescope is changing the way we look at everything from tiny dust grains in our galaxy to the most ancient starlight ever seen. It's like we've finally put on glasses and can now read the fine print of the universe. As more data comes in, the scientific community anticipates even more surprising discoveries about black holes, cosmic inflation, dark matter, and maybe even signs of extraterrestrial life. Final thoughts and call to action. The James Webb Space Telescope has already transformed astronomy. Its infrared capabilities allow us to see through cosmic fog, detect chemical fingerprints, and travel back in time, all from a quiet vantage point in deep space. What do you think about these revelations? Could we be on the brink of answering one of humanity's oldest questions? Are we alone? Let us know in the comments. If you enjoyed this video, be sure to like, subscribe, and turn on notifications so you don't miss our future explorations into science, space, and beyond. Thanks for watching, and we'll see you in the stars. Outro.